Now that you have learned how to assign permissions to a file and directories using letters, but now do you know you could also assign permissions using numerical values? Yes. So every time you have a file, you could assign permissions to that file or directory using numerical digits. And how does it work? So you know chmod UGO is for user, group and others plus R to a file will actually assign a read permissions to everyone. And if you want to use a numerical way, you could do chmod 444 and the file, which will assign exactly the same permission as in the first command, and the end result will be read, read and read permissions only to everyone for a file. Now how does the 444 changes and assign that permissions? Let's look at it by looking at the structure of a file. So as you all know, owners assign permissions on every file and directory, and we have users, and they have three types of permissions: read, write, executable. Group has three types of permissions, and everyone else or others or all have those three types of permissions as well. So we all know that. Then let's go more specifically that the first three bits that we have already covered are for the users, the owner of the file. The second three bits are for the group, and the last three bits are for the others. Now moving on, the table below that I am going to show you is actually assign numbers or permissions to the permission type. So let's look at that table. This is the table. It's something that you need to remember. Now if you have 0 assigned, that means no permissions. 1 is for executable, 2 is for write, 3 is for executable plus write, 4 is to read, 5 is to read and execute, 6 is to read and write, and 7 is to read or write and execute. Now how does these all 8 numbers work? If I do chmod 764 to a file, then it means the first digit will always be for the user itself. So 7 meanings, if you look at the table, it means this is going to assign read, write and executable permissions to the owner of the file. The second letter, which is in this case is 6, it means that read and write only that will be assigned to the group. And the last one is 4, that is for others, and the 4 means only read. So only read will be assigned to the file. So again, first digit is for users, second digit is for group, and third digit is for others. So let's try it in our Linux machine, in our lab machine, and see how it works. So I'm going to create a file, let's say test. I'm going to touch and create a file, test. I will do ls-ltr and the file is there. By the way, I am logged in as myself and I am in my home directory. So let's clear the screen by typing clear and do ls-ltr again. And you will see the test file is all the way at the bottom. Now by default, I have given the permissions as read, write, read and read. If you wanted to change these permissions to 764, meaning me as myself will have read, write and executable, and group will have only read, write and everyone else will just have read, then all I have to do is chmod 764 test. Now when you do ls-ltr, you will see right at the bottom I have now read, write, executable and read, write for the group and just read for everyone else. Now if I wanted to remove those permissions, let's clear the screen and just do ls-ltr only on test file. So just only that file shows up on the list. If I wanted to remove every permissions of everyone else, I will do chmod 000 test. Do ls-ltr by hitting up arrow key, which will bring the last run command, and you will hit enter. You will see all the permissions are gone. Now if I wanted to, let's say if I wanted to assign read and write permissions only to myself, then how are you going to do it? Then all you have to do is chmod myself would be the first digit, so I just want read and write only, so that would go for number 6, because if you look at the table, number 6 is only gives read and write. Then the rest I don't want to assign anything else, so you cannot leave anything empty like that, so you have to leave 0 0, so no permissions at all. Type test. Now if you do ls-ltr on test, you will see I only have read and write. So let's try one more time. What if I wanted to keep the permissions read and write, and I wanted to assign read permissions to the existing permissions for others, meaning right here. The last 3 bits I want are here. So for that, I would do first of all chmod, and of course I wanted to keep the permissions, and that permission is 6. For group, I don't want to assign anything, and for others I want read only. And if you look at the table, the number associated with read is 4. So if I do hit 4 and type test, and now if I do ls-ltr on test, you will see read and write, and read is only given to others in this case. Let's look at one more and last one example. What if I wanted to assign executable permissions to everyone in the system? So chmod. Now what executable permission? If you look at it, it's number 1 from the table. So that means 111, because I want to assign executable to myself, to groups and to others. So 111 and test, and let's do ls-ltr, and you will see it's only giving xxx. So now you got only executable. If you wanted to have executable and read, then you would have given number 5 and 11, which will give you yourself executable and read, and the rest only executable. Anyway, that's how you use this table, or that's how you use the numerical digit to assign permissions. Also, if you do not remember this chart, or if it's not handy with you, you could also go online. There are many calculators online that you could use. All you have to do is type online chmod calculator and it will come up. A lot of websites have those free calculators for you. By the way, in the next video I will show you how to calculate permissions and the major drawback of numerical permissions. Thanks for watching this video. If you like the video, then please hit that like button, and if you are new to my channel, then please do subscribe to my channel, because I believe knowledge is the key to success. See you in the next video.